G'day and welcome. My name's John Vile, and I'm here for day 3 of the Start Creating Robots challenge, or of course, robot arms. We're going to look into robot arms. So let's get into it. So to start with, why is this hard, or why is this important? So yesterday we looked at autonomous navigating robots and how that could be challenging. But what about robot arms? Are robot arms also tricky, or are they straightforward? So the problem with the robot arms is that you have a lot of joints that you need to move. So you can see this robot is actually fairly simple. It's probably got a base joint that allows it to rotate in this direction and probably in that direction, and then it's got your elbows and your wrist joints and eventually your gripper joints. And so these are basically a lot of things to control. And ultimately, as a user of a robot, you don't really care about what angle your joint is. You maybe care about whether the end of your robot is able to pick up this box, or whatever it is that your task is. And additionally to that, you probably want to make sure that when your robot moves around, it doesn't run into itself or run into other things in the environment. And so building a robot system that is able to, move its joints so that the end effector gets to where it's got to go, as well as being able to avoid hitting itself or objects in the environment, is actually pretty tricky. And so, what we can do is we can use open source tools like the ROS Move It to kind of solve this problem for us, so we don't have to think about it all too hard. Okay, so here we are in the Docker container. So make sure you have Docker running. You have to run that Docker run command from day one, and then open a web browser, localhost port 6080. We're going to open VS Code here, and it may open up, or it may, in fact, you may have to go open folder like we did on the first day. And what we're going to do, once you're in the Start Creating Robots folder, we're going to go Control-Shift-P, Run Task, Mackie Gazebo. And what this will do is this will start up a simulation of the Mackie Gazebo, well, the Mackie arm in Gazebo. So if you go and have a look at the simulation, there's a little sensor in the top there, and there's also this robot arm. You can zoom in a little bit to see it, and we've got this gripper. So what we're going to do is we're just going to control this gripper and show you how to control it. So the first way to do it, and I might just move this around here. So one way to control the gripper is to make sure you selected the gripper planning group, and then change goal state to closed. Hit plan and execute. And what you'll see is this shadow of the plan that's moving as it's going. If we go here, we can see that the gripper moved to that position. I might change the velocity scaling so that things happen a little faster. I'm going to move it to the open position, hit plan and execute, and you can see we move a lot faster. So that's how you control the gripper. So if you want to open and close the gripper on something, that's how you do it. And now what we'll do is we'll use UR5 control, and we're going to control the robot arm. The cool thing about controlling the robot arm is that we get these little handles in this viz, in our viz, that we can use. And so what I might do is I'm just going to use these handles to move the robot arm up to there, hit plan and execute, and we rapidly get our robot arm moving to position. So that's pretty cool. But one thing, and so now you can imagine you can use this to move the arm to wherever you like, especially if you click approximate IK solutions, you'll be able to move this around. You'll notice where it goes red is where it's detecting a potential self-collision. And what we might do is we might move it down here. Now, the problem is sometimes when you give it big movements like this, it can struggle to find a solution. So let's see if we can get one. And we did get one. All right, so now we've got the robot arm has been moved down to a sort of down position. And so you can do that. Feel free to play around moving your robot arms around in the simulator. But just like with Crichton, we could be a bit annoying and add obstacles to the environment. Because our robot arm is equipped with a perception system, we can add, say, an annoying cube right here. And so now I've added this annoying cube. What we should see in the visualization here is that it becomes a part of the of the cloud. And so this is an obstacle that the robot will have to try and avoid if it wants to go somewhere. So let's see if we can make it a difficult path planning by see if we can get the robot to move to a position that would require where the easiest path for it to go would be to go through the box. So I just gotta click this guy. Okay, cool. So that is, I've just got a self collision, I believe, right now. Okay, cool. Let's see if we can get it to go just next to the box. Without colliding. Let's see how we do. So that's pretty close. You know what, for good measure, let's add another box, sort of annoyingly placed, so there's a bit of space, but also to give us a bit of a challenge. Maybe let's put one right here. We'll need to wait a few moments for that to be added into the perception system, and then what we'll be able to do is we'll be able to see if if it can plan a path going to that pose but avoiding hitting either of those two boxes. So you can see that the easiest path to swing around would end up going into those two boxes. So let's see how we go. And it turns out that it has found a path that's able to avoid contact with any of those two boxes. And so that's really cool. So this allows you to create robot arms, tell them where to go, and also give them some sense of the environment so they can avoid obstacles and other issues as they're driving around. So that's all for today. I think that's really interesting, and it can be quite complex to set up. So if you're interested in understanding how to set up, how to use MoveIt to set up a robot arm, and how to set up the perception system so you can get the sorts of things we saw today, you can just use the source code. It's freely available and you can play with it, or you can come and join my Become a Roboticist course and we'll hang out and we'll try and build robots together. For tomorrow, we're going to start looking at how to use CAD design to create sort of any kind of robot that you like, anything that you can imagine and design in CAD that you can build. So anyway, I'll see you tomorrow. Bye.